All right, thank you everybody for joining us. We're here to talk about globally distributed video transcoding and streaming with a combination of Storj and Livepeer. So my name is John Gleeson. I'm Chief Operating Officer for Storj Labs.
And I'm Eric Tang. I'm the co-founder and CTO at Livepeer.
So for those of you who don't know about Storj, Storj is a decentralized cloud object storage provider. We have a globally distributed network of 22,000 nodes in 100 different countries. And those nodes are operated by 5,000 or 6,000 different people. It's one of the most distributed and decentralized networks out there today. Of course, we're completely open source. And because of the characteristics of our network, we're really optimized for use cases like video streaming. When you have a distributed network like this, there are a lot of things you can do to make it go really fast. We're optimized to take advantage of all of the bandwidth of all of those distributed nodes that are all over the world. We are able to do things like long tail cancellation to make sure that even though we're distributing files over a lot of different places, we're always getting the fastest nodes to deliver our content. We're able to minimize coordination. We don't have anything in the critical path of file delivery to make that go slow. And of course, the parallelism, being able to transfer pieces from lots of nodes at the same time, gives you a huge performance boost. It might be helpful to talk a little bit about how we store data on the network, and then we'll talk a little bit how we stream it out. Every object that's stored on Storj is first encrypted. It's encrypted with keys that only you have. So your keys are your data. Every piece of data stored on the network is encrypted so that no node, no provider, no one at Storj, no one running any node in the environment can have access to your data. Every encrypted object is split into lots of pieces, as few as 80 and as many as thousands of pieces, depending on the size of your file. And those pieces are distributed over our entire network. And then when you want to download your file, it's just the same thing in reverse. You download the pieces, you re-encode them, and you decrypt them. Now, that's a really fast process, and our software makes that really easy. And if you want to see a demo of just how that works, we have a little demo that shows where your pieces are uploaded on an ongoing basis. These presentation materials will be available afterwards, so you can grab the QR code and check it out. Of course, Storj works with a lot of different providers in video management and collaboration space because video streaming is such a great use case for us. And one of our premier partners in the video streaming space is Livepeer. So our slide didn't load. OK. So, Eric, do you want to talk a little bit about Livepeer and what you do in the transcoding space?
Yeah, for sure. Hi, everyone. Livepeer is a globally decentralized video streaming network that we started out in 2016, 2017, as building very closely with the Ethereum core developers. At that time, we were building video streaming into the Swarm network, which was this kind of the storage provider for Ethereum. And over time, Livepeer really started to focus on a globally distributed video transcoding infrastructure. And for those of you who are like, what's transcoding? Well, transcoding is actually the kind of the linchpin mechanism that makes video streaming works at scale on the internet. So when you're watching a Netflix video and it starts a little grainy and then it goes to kind of a high resolution view, that's actually transcoding working in real time to make sure that you don't have any buffering in the video and like in your viewing experience. The problem with transcoding is that it's very, very expensive. It requires a lot of computation power, and it requires a lot of data bandwidth to kind of move that data around. That's why working with Storj has been really exciting, because there's all this data, and video data is being stored inside Storj, and Livepeer can help transcode that and make the video streaming experience even smoother for the end user.
So one of the great things about working with someone like Livepeer is that we're solving both sides of the equation. So if you want to have a video streaming service, first you need to start with your video, you need to transcode it, you need to host the transcoded pieces somewhere, and then you need an OTT player to stream those pieces so you can actually watch the video seamlessly. And that OTT player is taking account of how much bandwidth you have, it's downsizing the video to optimize your experience for the bandwidth you've got. And so this is a great example of an end-to-end solution where a customer can actually go use our two products in conjunction together seamlessly, just as they would Amazon or Google or any other provider, and have a great solution. But the main benefit for that solution is it's about 90% cheaper when you combine our two products than using a comparable service on Amazon. We have a joint customer who's very excited to use both of our products together because they dropped their bill by a 0. They lopped a 0 off their bill, going from Amazon to storage. And they're going to take it down another 20% by adding transcoding, and they'll give their consumers, their customers at the end watching those videos, a better experience in the end of the day. So we're going to walk through a Transcoding Lab today to actually show you how this works. And because we have conference Wi-Fi, we're not going to attempt to do this live. However, you can join us at the sponsor showcase tomorrow through Sunday. We'll have people in the booth. Eric will join us there as well. And you can actually test this out, try it for yourself, and see how this works. So we'll walk through just what the steps are in the presentation today, and then we can also open this up for questions. And so the main things that we'll show you in this Transcoding Lab are how you create your Livepeer credentials. And so the credentials in Livepeer are how you get access to the system. I don't know if you want to talk a little bit more about under the hood, what goes on. And
yeah, so when you're uploading video kind of into the Livepeer network for transcoding, that video is actually being chopped up into small bits and distributed around the world to these transcoding nodes that are running GPUs on them. GPUs are very effective and efficient in transcoding video, and it's about 50 to 100 times more efficient than CPUs. And using Livepeer to transcode video represents the same amount of kind of savings as you compare to something like Amazon. So all that video is being transcoded, and there's a protocol that runs on the Arbitrum network that makes sure the transcoding work is done in a secure fashion, so when the transcoded job kind of returns a result back to a storage bucket, in this case in storage, you can be sure as a developer or as an end user that's using the application that the video that you're getting is the one that you have uploaded, but now you can stream it in an optimized way.
So when you're interested in sort of following up on what we've been talking about today, everything we have is in our documentation. So you can get the materials, you can use this QR code now, and there's a step-by-step set of instructions on how to do everything that we're going to talk about today. And one of the things I love in Web3 is using projects that really work and work really well. And I've used Amazon for transcoding in the past, and I've used Livepeer. And this morning, I was just uploading and downloading a video and walking through it and just making sure that everything, I had the flow down. And it works phenomenal, and it's fast. And when you think about that, all of that transcoding happens, you upload a video, and it's done in 2 or 3 minutes. And you've spent 90% less than Amazon, and the results are amazing. So everything you'll find that you need is in this lab. So your first step is going to Livepeer, and that's livepeer.studio. And you'll create an account. So when you create an account on Livepeer Studio, then you have an immediate access to create an API key. And you want to talk a little bit about that experience?
Yeah, so you just go in, you sign up for Livepeer. It's free to sign up. The Livepeer Studio application is a gateway service to the Livepeer network. Think of it as like a Infura for the Ethereum blockchain. And once you go there, you go to the developer tab, and you can create an API key, and then you're ready to go.
So once you've created your Livepeer API key, next you need to create your Storj API key. And you can go to storj.io, and that'll link you to our satellite interface. And just as Livepeer has an Infura-like interface, we have an Infura-like interface where you log in and create an account. Livepeer comes with 1,000 minutes a month of free transcoding as a free tier.
That's right.
And then Storj gives you 150 gigs of storage and bandwidth also. So you can do your whole lab, you can do this testing without committing to anything, and you can see how well all this works for free. So when you go into Storj, you'll just go down to the access grants, which is where you create credentials, and you can create a set of S3 compatible credentials. So you would use this application just like you would any S3 endpoint. So Livepeer is great because it works with Amazon, Google, Microsoft, Wasabi, Backblaze, almost every single storage provider out there, plus Storj as a decentralized storage backend. And so once you've created your credentials, what you'll want to do with Storj is just create a bucket and upload your first video. You can use any S3 compatible tool. You can use our CLI, you can use our clone, or you can use the web interface and just drag and drop your video into the browser. One thing you'll find that's really important is when you're creating these credentials, when you're creating an interface, it asks you to set an encryption key. That's done client side. Even though it's in the browser, it's still client side. But don't lose that key, because when you set that encryption passphrase, that key is your data. And so if you lose that and you try and go back and get it later, all you'll be able to do is download the encrypted asset, which is super unhelpful. So remember, save your key. And once you've got your access credentials, your key is actually encrypted and embedded within those credentials. So the next step is you run a script. And within that script, what you're setting is you're setting the Livepeer API key. You're adding in your Storj S3 credentials. And you're setting both the source of where you uploaded your file, and then you're setting your destination. Where do you want the transcoded assets to go? And then there's a little section there to set which transcoding levels do you want. And so do you want to talk a little bit about the importance of establishing those credentials and the formats? Yeah.
So it's important to set the storage key correctly so that you can the video can be transcoded and put back into your storage bucket. And when you're setting the transcoding profiles, we call them bitrate ladders. That's where you can set kind of based on how you want your users to consume the actual video. You can specifically set these settings. So for example, if you think a lot of your users are going to be on mobile and they're going to be walking around and have shaky bandwidth connections, then you want to make sure that you have a maybe 480 or 360p version of that video, so it can work very well in low bandwidth conditions. Or if you know that your video is going to be a 4K full HD and you want people to be experiencing those 4K full HD profiles, you want to make sure you set that as well. So you just set up all the profiles. There's also a default one if you think it's just kind of like a regular video on demand use case. You don't need to set anything, and the Livepeer network will pick a default solution for you.
So, for example, if you were at a conference, you may want to go all the way down to like 240 or 120.
Right.
Yeah,
that's right.
Right on. All right, and so once you set this up, it's relatively straightforward. You run the script, and it will go through, and it will transcode your assets. And so what you'll see when you sort of are looking at the storage interface, you can either use our web browser or CyberDoc or any other asset. You'll see your original assets that you uploaded, so the video that you're going to transcode. And then when you're done, what you'll see is you have a long list of these smaller objects. And what's happened is the transcoding process. Should I tell them what the transcoding process is, or do you want to actually tell them what the
sure.
I suppose I should let you do that.
I'll say a little bit. So the transcoding process, we talked about kind of it breaks up the video into small chunks, and then it transcodes them into different versions. And what you're seeing here is the one video file being represented in those small video chunks. We call them video segments, right? And in online video streaming, you use this thing called HLS, which is a standard that's established by Apple. They own the phone, so they kind of own the standard. And what the end device, the viewers are doing is they're downloading each of the little segments in sequence, right? So and then here's where the magic comes in, because if your bandwidth connection all of a sudden drops, the video player is smart enough to start downloading the lower bitrate version while continuing to play the same video. So you may see the video become a little more grainy, but you won't see the buffering. And that's a really important step to make sure users continue to stay on your website and viewing the video from start to finish.
One of the great things about Livepeer also is that you could have this dynamic bitrate with HLS, but also if you just have a website, for example, and you're only doing the video, you can also encode into just standard MP4 files.
That's
right.
And
so instead of having lots of little files, you can have the whole file. And the cool thing is that when using the player in either model, you can byte range seek. So you can skip ahead, and it doesn't download the entire video. It only downloads the byte range that represents the segment of video where you're watching. So it's really fast, so you don't have to have that caching and long loading experience. So one of the next steps is once you have that video transcoded, you just need to create a shareable URL. And we have a service called LinkShare, and LinkShare just creates an HTTP string that represents access to a file or directory. So you can share a whole directory. In this case, this is the directory of all of the video assets together, so that you can send it to a player, and then the player is smart enough to know what to do with that. Now, you can use LinkShare to send an individual file. You can use it for streaming video. You can use a lot of things, but it works great with the Livepeer OTT Player. Because again, when you're putting our two products together, the storage service simply stores the data and allows it to stream out efficiently and really fast. Livepeer handles all of the transcoding, but also offers the OTT player that knows what to do with all of those tiny pieces. And so when you take that shared URL, and again, you can use a variety of tools to do this, and you can script it however you want in your application. Ultimately, what you get back is a streaming video player that you can embed into your application. One of the interesting things about this is, as you're sort of using Storj plus Livepeer, that whole savings experience is really good, but sometimes people think, well, is it good though? Yes, I'm saving a lot of money, but ultimately, what's the user experience like? And we have a joint customer, and that customer does something like 400,000 streams. Is it 200,000 a day? Something like that. It's a lot of video streaming. They have customers all over the world, and this thing works seamlessly. We have this customer is excellent. We will be doing a webinar with this customer in the next month or two, but it's a fantastic end user experience. This works, and it's one of the things that gets me really excited about Web3 when I see something that gets a customer happy, who's coming out of Web 2, who's dissatisfied with Amazon and $60,000 Amazon bills, and they're looking at a $10,000 or $12,000 bill at the end of the day after using a combination of our services, and that's fantastic. So when these videos are streaming, one of the other cool things that's going on in the background is when you sort of byte range seek to a video or when you're playing, that video is actually distributed out across thousands of nodes all around the globe. And when you byte range seek, you get maybe 20 milliseconds, 30 milliseconds of latency as you move the cursor forward. And one of the great things about that is that it's not just going to a CDN, it's not just going to a centralized provider like Amazon. It's actually reaching out and gutting byte ranges from thousands of nodes. And every time you seek, it's getting 80 nodes, it's finding 29 pieces, and it's downloading those in parallel, and then streaming that video right from your laptop or phone. It's incredibly fast, it's incredibly snappy, and for all of that going on, we're tapping into that latent capacity. We're tapping into that extra GPU all around the world. And it's delivering an end-to-end solution for customers. So if you want to know what's next, we have a Twitter live stream later this afternoon together. We'll be talking about this a little bit more, talking about the customer more in depth. You can learn more by going to the documentation page for our lab. You can join us tomorrow through the end of the week at the sponsor showcase. So with that, if there are any questions, please go ahead, and we're happy to answer them.
Oh, like that, like price decrease and price advantage, like that's a miracle in the decentralized space. Do you think that's a little bit of Amazon just being monopolistic?
So I think it's probably two things, and you could talk a little bit about how the transcoding pricing works, but the traditional approach to competing in this space is you build a building. You stuff that building full of servers, you stuff those servers full of hard drives, you connect the internet and power, and you call it cloud. That is an expensive thing to do. And so to enter that space, to compete against Amazon, is a crazy thing to do when they have so much money and they have so much economy of scale. So yes, they can keep their prices high because they're one of the very few people that can do it at that scale. And everybody else who's competing in that space is spending hundreds of millions to billions of dollars to do that competition. What Web3 brings is the ability to not do that. It's the first credible alternative architecture to compete in that space. Because what we're able to do is collectively tap into latent existing infrastructure all around the world. 22,000 nodes in 103 plus countries sharing hard drive capacity with our network. Aggregating that, making it available to how many nodes are you running right now?
Yeah, there's 100 operators, but tens of thousands of GPUs around the world running.
And so neither of us bought a server, built a data center, or stacked and racked a bunch of power supplies and redundant internet. It's like the Airbnb of internet resources, and bringing this together is basically a way to aggregate that resource, allow those individuals who have excess capacity to participate. As my buddy Kevin says, they can be the cloud, right? They can participate in this economy and earn money while doing this, and at the same time allow us to offer a service that's differentiated and that's a much lower cost point and a much better value for consumers. And this is a great way for Web3 to bridge into Web2 use cases.
Yeah.
So long answer to short question.
Yeah, thank you. It's incredible.
I mean, I think another thing to really think about is, a lot of people don't know that, even Amazon, as big as it is, it only represents a pretty small footprint for the total amount of computation capacity out there in the world, right? It's less than 10%. So there's a lot of computation capacity that we just don't think about on a day-to-day basis that are sitting in, warehouses, sitting in people's, server racks in buildings, right? A lot of those things are not being used. So, so what we see on the Livepeer network is not only the individual hobbyists that are, running GPU miners, but, there are, scaled and professional operators that actually have data centers and have latent capacity in those data centers. They need to monetize that somehow. So they plug into these decentralized networks, and that's a great way to kind of harness the latent capacity around the world. Right?
Yes, I have a question. What are some of the successful business models that your customers are using where end users are providing them revenue?
So if I understand your question correctly, that's who is paying to use this service? Is that what you're asking for?
Yes, that's correct.
Oh, great. So we have a range of customers right now. We have one of, I think both of our most significant customers is a company called Innovo, and they're a small to mid-size video streaming company, and they're one of those companies who they have that sort of narrow band of usage where they have a few hundred terabytes of storage, and they're doing low to mid petabytes per month of egress bandwidth, and there isn't really a tier of pricing for them in the main market size for them to be successful, right? If you're paying full freight on Amazon and you're paying $23 a month to store a terabyte, and you're paying $90 a terabyte for egress, your Amazon bill for that use case is $60,000-$70,000 a month, and that is just no bueno if you're trying to create a streaming business. However, if you look and say, okay, well, what does that look like if I use decentralized object storage and transcoding, and you're looking at lopping a zero off of that, getting anywhere in there from $6,000 to $12,000 a month for that same tier of service, right? It allows them to be very successful. Outside of video streaming, for us, we have a variety of use cases in Web 2. In addition, we have backup storage and a number of things in M&E workflow beyond streaming, media and entertainment workflows. And then inside of Web 3, we're seeing a lot of stuff. Growing areas with video transcoding is probably the biggest for us because that's one area in Web 3 where there's a lot of data gravity. And the other one is blockchain fast sync. So we have, for example, a storefront called chainsnap.io that's with Anchor, the node running group. So we have snapshots of chain states there that people purchase to spin up new nodes quickly and efficiently because nodes crash and you want to get one back online fast. And the fastest way to do that is to have a snapshot of chain state. And so that's another significant revenue driver for us because, again, if you're putting those chain state snapshots in Amazon and you're spinning up 100, 1,000 nodes a month all around the world, you're paying that Amazon egress full freight. Again, it's $90 a terabyte versus $7, right? So lopping a zero off that bill, if you have an event, you need to restart a bunch of nodes fast. You could have a $100,000 Amazon bill, or you could have a $4,000 storage bill. You want to talk a little bit about where you're seeing success?
Yeah, I think the kind of the cost advantage in this combined solution is actually quite significant for many businesses or many online communities that sometimes don't even have the ability to do video streaming at today's price point, right? So if you look at online video streaming, it's pretty monopolized, right? There are a couple of big players out there. These big players also happen to be owned by the big cloud providers like Google and Amazon and whatnot, right? So that creates a big problem, which is if you want to put your video on YouTube, you got to play by YouTube's rules, right? YouTube, we're getting to a point where YouTube kind of represents online video streaming, which is a huge problem because they set the rule, they set how content is being monetized, and what you see is now that there's this commoditization of online views, right? Where people are trying to rack up millions of views per video on YouTube, and each view counts for a fraction of a penny. It commoditizes the value of the video, and it starts to get everybody's attention, right? So I think there's an opportunity here for us to start to think about, like, by knocking down the infrastructure cost, it gives all the application developers an opportunity to start building niche video streaming applications that actually serve niche communities for the needs that they actually have, right? So Innovo is a great example. They have a really niche use case. They have a niche audience, and they don't want to put their video on YouTube. And if they were just using Amazon, well, that cost of running business is going to run them out of business, right? So yeah, like, I think in the next couple of years, what we're going to see is video streaming continue to grow. The amount of video on the internet continues to grow, and the amount of niche applications, niche use cases will continue to grow.
And again, that price point and that value enables those smaller parties to actually have a real business model where they just don't have an option today. This provides that solution, which is great. And you see that popping up in areas where there are oppressive regimes and people don't have access to certain properties and assets. They can use these services to be successful. Over here. Got it.
Hi, so both of you described gateways that are kind of Web 2-like that make it easy to use both of your decentralized networks. Are there other gateways that exist besides the two that you mentioned? And what's the plan to ensure that if one of those gateways gets attacked, like legally or otherwise, that the network still remains accessible for that kind of price and that ease of simplicity?
Yeah. I can talk a little bit about that.
You go first, and
I'll talk a little bit about that. It's true that gateways are kind of potential single points of failures, right? So right now in the Livepeer network, Livepeer Studio is the main gateway service that allow people to access the Livepeer network. But there are other services in application developers in the Livepeer ecosystem that operate their own gateways. Right, and they know how to kind of if they have a little bit of DevOps chops, they can spin up those services. We have this thing called the Livepeer Catalyst, which is the Gen 2 of the Livepeer node, and that Catalyst software is a video transcoding node, but it also is a full media server that does everything from video ingest to service to everything, right? So if you want it, you could run a globally distributed Catalyst node cluster and run your own gateway service, and of course, for Livepeer Studio, Livepeer Studio has to follow certain rules, right? Like if we get a DMCA takedown notice from the government, we have to take certain content down, right? But there's always this alternative for alternative gateway operators in the ecosystem.
Yeah, we're in exactly the same space, right? So we run gateways. They're highly available, globally distributed, multi-region, and all that good stuff. And again, because we are running them as Storj Labs, we have to play by those rules as well, the DCMA takedown notices and things like that. And just as a responsible operator, we have to do those things. If someone else wants to run a Storj satellite, which is the entry point to the creating access credentials and all those things, it's open source code, and you can someone with reasonably good DevOps chops can do that today. We have a video on doing that, and we have a bunch of documentation in the works to make it easier for third parties to go run their own. And same thing with the edge services, which is the S3 compatible gateway, which talks S3 on the front end and storage protocol on the back end and does all of the encryption, erasure coding, all of that good stuff. Anyone can run one of those as well. So you can also split the baby and go use any gateway with any combination of satellites. So if you want to run your own satellite, but you don't want to host your own edge services, you can use your satellite with our edge services or anyone's hosted edge services, or vice versa. Stand up your own edge. And again, the advantages there are just simply control, cost. If you want end-to-end encryption and you want to have absolute maximum control of your data, all the pieces are there for you to go do that. All right, so we have 17 seconds left, and we were told that was our last question. So thank you very much for joining us. Again, you can find us in the Storj sponsor booth the rest of the week. Our social info is up on there, so you can tap into the deck when they post it. And all of this information is in the Storj documentation, and it's also in the Livepeer documentation. So thank you.
Thank you.